Okay, so now that we've learned how to multiply rational expressions, we're going to go ahead and just practice a couple more examples. So let's go ahead and work through these. Maybe pause the video. Try to take a minute on your own to see if you can work through these problems. So go ahead, pause the video for a couple minutes and come back in 2 or 3 minutes. Okay, so let's assume that you all mastered it really quickly and everybody understands exactly what's going on, right? So I'm just going to work through these, reminding us of the process here. We know we need to multiply the numerators together, multiply the denominators together, and also simplify our expression. You'll remember that simplifying means factoring and canceling. And what we said in the last example is, in fact, we can do the canceling at any point in the process, even before we multiply. And I would recommend that as probably a preferable strategy. So what I'm going to do here is I'm actually going to factor and then cancel any common factors I can before I multiply. So let's go ahead and look at these here and try to factor our factor each expression. So on the top left I have 12 times b. I can rewrite that as 3 times 4 or 2 times 6 if I want, but I don't know what's going to cancel yet. So I'll just leave it as 12, but make sure you notice it's 12 times b, so you have that common factor of b, or I should say a factor of b, which might be common with something else. Now I'm going to go to the bottom left. In the bottom left I see a common factor of 5. So I'll take out the common factor of 5. It leaves 5 times b plus 3. I'm crossing that out to make sure I'm only looking at the factored form now. I'll move on to the top right. Top right, hopefully we see quickly, is a difference of squares. So it'd be plus 3b minus 3. And in the bottom right, we have a common factor of 3b in each term. So we'd have 3b, and that would leave b plus 3 as the remaining factor. Now I'm going to look at all of my factors. And remember, we can cancel across a multiplication sign. So any factor that is common in the numerator to the denominator can be canceled. So as I scan across, I see I have a common factor of b with b. So I have a b in the numerator and a b in the denominator, so I can cancel those. I also see that I have a b plus 3 in the numerator and a b plus 3 in the denominator. And then I'm a little bit tempted to cancel these, but I can't because one is b minus 3 and one is b plus 3. And then we'll see if there's any common numerical factors. I have this factor of 3 here. Well, 3 can cancel with 12, and it leaves 4 behind. And now we want to carefully scan across the top and the bottom to line up all of our remaining factors. So in the numerator I have a 4 and a b plus 3, b minus 3, b minus 3. And that's it. That's all I have left from the numerator. In the denominator, I have a 5 and a b plus 3. And that is my fully simplified factored form. Because it did ask me to multiply in this expression, I can go ahead and multiply this if I want. If I did multiply this through, I'd have 4b minus 12 over 5b plus 15, and I could leave my answer like this. Personally, I'm fine if you leave it in factored form. I don't know that one is really better than the other, but since it asked to multiply, we went ahead and multiplied here. And that's how we would multiply these rational expressions together. If I come down here and look at this example, number 3 here, same idea. In fact, this one is much simpler to see the common factors. I don't need to even bother factoring. I can cancel out a common factor of a. And then I hopefully also see a common factor of 5. That leaves 4 in the denominator, which would leave, if I scan across the top, all I have left is 3. And in the bottom, I only have 7 times 4, so that's 28. And there's my simplified form. Right. So multiplying rational expressions, real simple. Multiply the numerators together, multiply the denominators together. Be very careful to cancel all common factors, canceling only common factors. Just again, to remind us, these b's might be tempting us to cancel, but we cannot cancel them because they are both terms. attached to a subtraction and addition. So we cannot cancel common terms, only common factors. So we would leave that one like it is. All right, so you're hopefully seeing here the importance of factoring. As we've talked about, we spend a lot of time getting really good at factoring. You need to be very good at it to excel in this unit. So in the interest of preparing for that, we're going to have that quiz on factoring that you may have been thinking I forgot about on Monday. We're going to move that and have that tomorrow, Friday. So be ready to practice or to exhibit all of your factoring skills tomorrow on a quiz. Practice that tonight if you need to, but it's really crucial that we're really, really good at factoring. Okay, so review all of your factoring skills. It won't be as difficult as some of those worksheets were, but you should anticipate all the different techniques being on the quiz tomorrow.